In this video, we want to find the area of the region bounded by the graph of the rational function y equal x over x squared plus 1, the line y equals 0, which of course represents the x-axis, and the vertical line x equal to 3. So let's look at the rational function first, y equal x over x squared plus 1. Notice that if I let x be 0, got 0 there, 0 here, so that'd be 1. 0 divided by 1 is 0. So I know that the graph of this function passes through the origin, 0, 0. I also know that because we have x squared plus 1 in the denominator, and x squared cannot be negative, x squared plus 1 is always going to be positive because of the x squared and the plus 1. So if I pick values larger than 0, this particular graph here will be above the x-axis, to the right of the y-axis. If I pick values less than 0, that is to the left of the y-axis, the graph will be below, because the negative y will be below the x-axis. So with that in mind, all we need is a rough sketch of the graph here. So it goes something like this. I know it passes through this particular point here, the origin, 0, 0. And then to the right, x positive, or positive values of x, the graph has to be above the x-axis. And for values of x that are negative, the graph's going to fall below the x-axis. And because let's look at the equation here, x over, or f of x equal to x over x squared plus 1. The denominator, as x increases, is going to get larger than the numerator. So the graph is going to go up, but then as the x value increases, the y value is going to decrease. So it's going to come back something like this. So the x-axis is going to be a horizontal asymptote. Now if I pick values to be negative, denominator is still going to be positive. The graph's going to come down like this on the left side. And then as the x value increases, it's going to go back up like this. So we want the region bounded by this graph, the line y equal to 0, which is the x-axis, and the vertical line x equal to 3. So let's say x equal to 3 there. So we want this region right here. That's the area we're looking at. And because of the given information, the definite integral will go from 0 to 3. So again, the area of this region will be a definite integral from 0 to 3. And if I draw a rectangular strip here, representative of the area here, it's the top curve minus the bottom curve. The bottom curve is, of course, y equals 0. So this is just going to be x over x squared plus 1 minus 0, because that's the bottom curve, top minus the bottom. So it's just a matter of integrating this integral right here. Notice the derivative of x squared plus 1 is 2x. I only have an x there. So if I were to use a u substitution, this would come out like this. This would be u, and the derivative of that is 2x. I need a 1/2 here, so this would just be 1/2. And it's ln of absolute x squared plus 1. But x squared plus 1 is never negative, so I don't need absolute value here. I just put 1/2 natural log. of x squared plus 1. And of course, because I have a definite integral to find the area, this goes from 0 to 3. So it's going to be 1/2. Put a 3 here. 3 squared is 9 plus 1 is 10. So this will be natural log of 10. And then put a 0, evaluate it at 0. So it's minus. First we evaluated 3. We get this. And then we have minus the value of this expression at 0. Well, if I put a 0 where the x is, the 0 squared is 0 plus 1 is 1. Natural log of 1 is 0 times 1/2 is still going to give me 0. So I'm left with 1/2 natural log of 10. That's the area in square units. If I use a calculator, compute this out, this will be 1 to 2 decimal places, 1.15 square units. Thanks for watching. We'll see you next time.